this video, we're going to talk about trigonometric relationships and identities. We've already talked about in previous lessons the relationships for a right triangle. When you have a right triangle and you can focus on the legs as well as the hypotenuse. So remember, the side opposite the right angle is your hypotenuse. Then the other legs are based upon the angle. You have your adjacent side and you have the opposite side. Okay? And so we defined our 6 trigonometric relationships for that. One of the things about those right triangle relationships is we're limited to an acute angle, an angle that measures between 0 and 90 degrees. We then defined our relationships in terms of the unit circle, which lets us consider ordered pairs that are points on the circle where you have a radius of 1, and we defined those 6 definitions. And if we take those, primarily our unit circle relationships, we can then extend those and create other relationships as well. So for example, we have, and I mentioned this earlier in a previous one, we have what are called the reciprocal identities. Now, you may recall from algebra days that an identity is a mathematical statement that's always true. It's sort of like a theory or a law in maybe a science class. An identity is a mathematical statement that is always true. We looked at this one in terms of the right triangle, and I even pointed out to you in the previous video that the cosine and the reciprocal are reciprocal identities, because if you look at their relationship, the cosine of an angle is adjacent over hypotenuse. But then when you look at the secant, the hypotenuse goes to the numerator and the adjacent goes to the numerator. So basically you've flipped it over. That's the idea of a reciprocal, is like the flip. And so then you also have sine and cosecant, and tangent and cotangent are reciprocals of each other. Those same relationships exist in the unit circle, in that cosine represents the x coordinate of the ordered pair, and the secant is actually the reciprocal, which will be 1 over x. But we could also, instead of using x, that we could then use the actual trigonometric relationship. So cosine is also recognized as 1 over the secant. It's the reciprocal of the secant, and secant is the reciprocal of cosine, so we can write it as 1 over cosine t. Those same reciprocal relationships exist between the sine and cosecant and tangent and cotangent. So you have the reciprocal identities. Also, you have what we call the quotient identities. The definition of the tangent in terms of your ordered pair is the y value divided by the x value. And so if we use that idea of substitution, we know that the y value corresponds to the sine of the angle, and the x value corresponds to the cosine, so that we can rewrite that ratio or that quotient as the sine of the angle divided by the cosine of the angle. Similarly, with cotangent, you have x divided by y, which is our definition, and then again we use kind of the idea of substitution in that the x coordinate corresponds to the cosine and the y coordinate corresponds to the sine, so that cotangent is cosine t divided by sine t. Now these are called quotient identities because it looks like a fraction or a division problem. Then we have what are called the Pythagorean identities, and again they kind of stem from the definition of sine and cosine and in relationship to the formula for the unit circle. If you'll recall, for the unit circle, we have x squared plus y squared equals 1. So if I know, and I know that x is represented by cosine, okay, so I would have cosine squared, or cosine x squared, plus the sine x squared. Okay, so basically, again, what I'm doing here is I'm substituting the cosine and the sine for x. So in place of x, I put cosine. In place of y, I put sine. And so we end up with the relationship cosine squared plus sine squared equals 1, which is really based off of the Pythagorean theorem of a squared plus b squared equals c squared. And then I can change this around a little bit. You have kind of these two little sub definitions, and I get those sub definitions by solving the cosine squared plus sine squared equals 1, either for cosine, so that I have cosine squared equals, or I have sine squared equals. So it's the same identity, but it has different forms, and sometimes one form may be better than another. Now, to get to these others, if we take the original, and my pen seems to be giving difficulty today, cosine squared x plus sine squared x equals 1. And if we take and we divide that whole thing by cosine, so that I'm going to divide all of the pieces by cosine squared. And I apologize for the pen. It's giving me trouble this morning. Okay, so that gives us 1. Cosine squared over cosine squared is 1. Plus sine squared over cosine squared. That's the quotient identity, and that gives us the tangent squared x equals, and then 1 over cosine, that's the reciprocal. So we have the reciprocal of cosine is secant squared x. So that's how we come up with this relationship here, is because we basically take the original cosine squared plus sine squared and divide everything by cosine. And then again, I can algebraically manipulate that and solve it for tangent squared or secant squared. Similarly, to get the third one, if I take the original equation cosine squared x plus sine squared x equals 1, and this time I divide everything by sine. Okay, so I divide everything by sine. Then I end up with cosine squared over sine squared. That's our quotient identity. So that gives me cotangent squared x. Sine over sine is 1. And then I have 1 over sine. That's the reciprocal. And it's the reciprocal of cosecant squared x. So again, that gives us this third relationship. So everything stems, if anything, you need to learn the very first one, cosine squared plus sine squared equals 1, because you can develop the others from that one Pythagorean identity. And then we talk about even and odd trigonometric functions. Even and odd trigonometric functions. This stems, again, as a carryover a little bit from your algebra days. If you'll recall, in algebra, an even function is one that is symmetric to the y-axis, which means if you could visualize a graph on your coordinate plane, perhaps let's use a parabola. Okay, and you could visualize picking that parabola up and folding it in half. On that parabola, you would have the point x, comma, y, or you would also have the ordered pair negative x, comma, y, because they would fold on top of one another. And that's what this statement says. It basically says that you have, if you use x and negative x, you're going to get the same y output. If I input negative x, I get the same y value. If I input positive x, I get the same y value. So for an even function, you're going to have positive and negative x's with the same y's. With an odd function, if we think about an odd function is symmetric to the origin. So again, if you go back and think about one of your basic algebra functions, which would be your x cubed, in this particular one, you would have the ordered pair x, comma, y, and also negative x, negative y. So the odd function, if you input x, you get y. If you input negative x, you get negative y. Okay, so that kind of gives you an idea of, hopefully, a review of even and odd. And so we think about which of our trig functions are even and which of them are odd. There are two that are even. Your cosine is even, and your secant is even, which means if I input a negative angle value, I'm going to get the same output as I would for the positive angle for cosine and secant. Remember, those are reciprocals of each other. And then the other four, if you can remember that cosine and secant are even, then the other four are odd. Okay, so sine, cosecant, tangent, and cotangent are all odd functions. So if you can remember the evens, then you know that all the others are odd. And then we also have something called cofunctions. And the way it reads, it says cofunctions of complementary angles are congruent. Remember that complementary angles are two angles that add together to equal 90 degrees. And we say the angles are complements of each other. And so the definition looks kind of weird, but it says that the sine of an angle is equal to the cosine of 90 degrees minus that angle. So let me see if I can help you make sense of this. Let's say, for an example, we have a 30-degree angle and we have a 60-degree angle, okay? And hopefully you realize that those two are complements of each other, because 30 plus 60 is 90 degrees. So let's think about this. The sine, we're saying that the sine of 30 degrees would be the same as the cosine of 60 degrees. Okay, and if you look at the unit circle, if you go back and look at the unit circle and look at the sine value for 30 degrees and the cosine for 60 degrees, you're going to find that they both equal positive 1/2. Similarly, if we look at, say, the cosine of 30 degrees, that should equal the sine of 60 degrees. And again, if I look at my unit circle, I see that the cosine of 30 degrees is square root 3 over 2, which is the same value for the sine of 60. So co-functions of complementary angles are the same value. And again, sometimes that comes in to play and is very helpful in solving problems. And so we use all of these trigonometric relationships and identities to help us solve problems, to find maybe if we have one or more of the trig functions and we can find all of the others. It also helps us to prove or verify other identities using these relationships. And so you need to become familiar with all of these different relationships so that you're able to use them in solving and simplifying problems throughout the remainder of the course.